Today we have Keeper 4.10, L'Hopital's rule. All right, so L'Hopital's rule is basically a rule that helps you to find your limits a little bit faster. In the event that when you initially plug in your value and you get 0 over 0, or infinity over infinity, negative infinity over negative infinity, you can use L'Hopital's rule very easily to reduce it down to get your limit a lot faster. So basically what you're going to do is you're going to take the limit of the top. You want to confirm that that equals 0, and then you're going to take the limit of the bottom and confirm that that equals 0, or infinity for either one of those. And once you confirm that both of them equal 0 or both of them equal infinity or negative infinity, L'Hopital's rule says you can simply just take the derivative of the top and divide it by the derivative of the bottom. All right, so here's an example. We have the limit as x approaches 0 of sine x over x. We saw this limit a while back in Unit 2, and we had to use the squeeze rule to evaluate this limit. But now we're going to look at it and do it in terms of L'Hopital's rule. So the very first thing I'm going to do is I'm going to take the limit of the top. So the limit as x approaches 0 of sine x is 0. Then I'm going to take the limit of the bottom. So the limit as x approaches 0 of x also equals 0. Once I recognize that those both equal 0, I know that I can apply L'Hopital's rule. Now, please understand that you do have to show this step. You do need to show that the limit of the top is 0 and the limit of the bottom is 0. You must show that as two separate steps in the process. So again, once they both equal 0, we're in indeterminate form. We have 0 over 0. So then I can use L'Hopital's rule, and I could take the derivative of the top over the derivative of the bottom. So again, I have the limit as x approaches 0 of sine x over x. If I take the derivative of the top, I get cosine x, and the derivative of the bottom is 1. Once I do that, I can simply plug in my limit. So I'll plug in 0, and I get cosine of 0, which we all know is 1. All right, another example. So again, I'm going to start by just plugging in the limit. So I'm going to plug in the limit to the top. So I plug in 1 into 5t to the fourth minus 4t squared minus 1. And I get 5 minus 4 minus 1, which is 0. And then I plug the limit into the bottom. So plugging 1 into 10 minus t minus 9t cubed, I get 10 minus 1 minus 9, which is also 0. Again, I confirm that both the top and the bottom separately equal 0. This is what we call indeterminate form. So once we see that indeterminate form, we can use L'Hopital's rule and simply take the derivative of the top over the derivative of the bottom. So the derivative of the top would be 20t cubed minus 8t, and then the derivative of the bottom would be negative 1 minus 27t squared. From there, I can simply plug in my limit, and I get 20 minus 8 over negative 1 minus 27, and simplify that to 12 over negative 28, reduce that down to negative 3/7. All right, so next example, we have the limit as x approaches infinity of e to the x over x squared. Take the limit of the top, I get infinity. Take the limit of the bottom, I also get infinity. And so I apply L'Hopital's rule. So the derivative of e to the x, we should know by now, is e to the x. And the derivative of the bottom x squared is equal to 2x. All right, so I notice when I do this that if I take the limit and I plug that limit in, I get infinity over infinity again. So I have to do the process again. So basically, you could do L'Hopital's rule as many times as you need to do it to get your final answer. So I take the limit of the top again, and I get infinity. And now I'm going to take the limit of that 2x that I found, and I also get infinity. So again, by L'Hopital's rule, I could take the derivative of the top over the derivative of the bottom, and I get e to the x over 2. All right, now if I plug in my limit from there, I get e to the infinity over 2. Well, we should know that e to the infinity is infinity, and so my final answer would be infinity. All right, next example. We have one of our little fractions, so we have 5 over 6 plus h minus 5/6 all over h. Again, I'm going to plug that limit into the top, and I'm going to get 5/6 minus 5/6, which is 0. And then I plug the limit into the bottom, so the limit as h approaches 0 of h is 0 as well. So again, using L'Hopital's rule, I'm going to take the derivative of the top over the derivative of the bottom. Now, by now, you guys should know that the derivative of your 5 over 6 plus h can simply be done using the quotient rule. And so if you use the quotient rule and you do low d high minus high d low over low low, you'll be left with negative 5 over 6 plus h squared. We should also recognize that the limit of 5, 6 is 0 and the limit of h is 1. So all I really had to focus on was this limit, or this part of my numerator. This was the only thing that was really relevant to me because, again, the 5, 6 went to 0 and the h went to 1. So once I do that and take that derivative, again, I can plug in the limit. And when I plug in the limit, I get negative 5 over 6 squared, which is negative 5 over 36.